Hello, aspiring Java developers. Welcome to a brand new tutorial on our channel. Today, we are diving into a fascinating and rapidly evolving topic, decentralized applications, commonly known as dApps. Have you ever wondered about applications that run without a central server, offering unparalleled transparency and security? Well, that's exactly what dApps are all about. In this 5-minute animated whiteboard session, we will demystify decentralized applications, understand their core components, and explore how Java developers can get involved in this exciting space. By the end of this video, you will have a solid foundational understanding of what dApps are and why they are becoming so important. Let's get started. Alright, let's begin by understanding the fundamental difference between what you are probably used to and what decentralized applications offer. Most applications you use daily, like social media or online banking, are centralized. This means a single entity controls all the data and servers. If that central server goes down, the entire application stops working. But with a decentralized application, there is no single point of control. Instead, it runs on a peer-to-peer network, typically a blockchain. Think of it like a shared, immutable ledger where everyone has a copy and no one person can tamper with the records. This structure enhances security and transparency significantly. Here's a simplified Java representation of a block, which is a fundamental component of a blockchain. Moving on, the real brains behind many decentralized applications are what we call smart contracts. Imagine a regular contract, but one that is stored directly on a blockchain and automatically executes its terms when predefined conditions are met. There is no need for intermediaries. These contracts are essentially self-executing code, and once deployed, they cannot be changed, making them incredibly reliable and transparent. For example, a smart contract could automatically release funds when a delivery is confirmed without any human intervention. This automation is a game changer for many industries. Let us look at how we can conceptualize a smart contract in Java through an interface and a basic implementation. Now, let us put these pieces together and understand the architecture of a decentralized application. A typical decentralized application has three main layers. First, the user interface, which is what users interact with, much like a regular web or mobile application. Second, the smart contracts, which handle the application's core logic and rules, residing on the blockchain. And third, the blockchain network itself, which acts as the decentralized database and execution environment for smart contracts. As Java developers, you can build powerful user interfaces for decentralized applications, perhaps using Android for mobile or Spring Boot for web-based frontends, and then use libraries like Web3 to interact with the smart contracts on the blockchain. Here is a conceptual Java example demonstrating how a client might interact with a smart contract. Developing decentralized applications comes with its own set of unique challenges, but also offers incredible opportunities. One common challenge is scalability, as processing many transactions on a public blockchain can sometimes be slow and costly due to gas fees. Another crucial aspect is security. Once a smart contract is deployed, it is immutable, meaning any bugs or vulnerabilities cannot be easily fixed, leading to potentially significant losses. To mitigate these, always prioritize thorough testing and security audits for your smart contracts. Embrace modular design for your code and focus on creating an excellent user experience, abstracting away the blockchain complexities for the end user. Remember, robust error handling and clear documentation are your best friends in this new frontier. And that brings us to the end of our rapid tour through the world of decentralized applications. We started by understanding the core difference between centralized and decentralized systems, then explored the foundational role of blockchain. We delved into smart contracts, the self-executing agreements that power decentralized applications, and finally, looked at their overall architecture and some best practices for Java developers. Decentralized applications are transforming how we think about trust, transparency, and data ownership. It is a vast and exciting field with immense potential. Keep practicing, keep exploring, and keep coding. If you found this tutorial helpful, please give it a thumbs up, subscribe to our channel for more Java content, and hit the notification bell so you do not miss our next video. Happy coding, and see you next time.